Welcome to This Explainer. Have you ever stopped to wonder if the world you see, feel, and experience every single day is actually the world as it truly is? Well, today we're going on a really fascinating journey inspired by Dr. Heidi Havik's book, The Reality Check. We're going to explore a completely mind-bending concept together. The reality you experience isn't actually out there. It's a custom-built virtual reality constructed entirely within the physical wiring of your own central nervous system. Okay, let's dive right into this because, as Morpheus famously points out in the movie The Matrix, our perception is really just biology. While we aren't literally plugged into some malicious machine, our brains are, for all intents and purposes, trapped in the pitch-black vault of our skulls. Think about it. Your brain has never actually seen a tree or felt an apple. All it ever receives are raw electrical sensory inputs from the outside world, and it has to interpret those signals to build a coherent picture of what's going on. So that begs the question, can you completely trust your own senses? Scientifically speaking, the answer is a resounding no. Your brain doesn't just passively act like a video camera, perfectly recording the world. It actively filters information based on your past experiences, your expectations, and your current environment. It's constantly making educated guesses. Essentially, there is no single objective, true reality that you perceive. There's only your brain's highly customized, highly edited interpretation of it. Let's move to Section 1, your inner virtual reality, and look at exactly how the brain fills in the gaps. Now, what's really interesting about this is that because your brain is processing literally millions of inputs at once, it has to take shortcuts just to keep your internal reality running smoothly. For instance, you can probably read that scrambled text perfectly, even though the middle letters are a complete typo-ridden mess. As long as the first and last letters are in the right place, your brain just guesses the rest. It's kind of like the ultimate highly advanced autocorrect. It does the exact same thing with the physical blind spot in the back of your eyes. Where the optic nerve exits, you actually have a physical hole in your vision. But you don't walk around seeing a black hole floating in space, right? Your brain just paints over it, guessing what should be there based on the surrounding scenery. This continuous rendering process is what neuroscientists call sensory-motor integration. In mere milliseconds, your senses gather up raw data, your brain filters it through your past, fills in those blind spots we talked about, and boom, it renders your seamless, custom-built reality. But here's the catch. For the brain to do this accurately, it desperately needs a continuous, reliable flow of high-quality data from the body. And where does a massive chunk of that data come from? That brings us to Section 2, the spine's hidden role. This is the brain's eyes into the body. You know, we usually just think of the spine as a stack of bones holding us upright, but it is actually a massive high-speed sensory data cable. Deep within the small muscles attached to your spine, especially right up at the upper neck just beneath your skull, are millions of tiny stretch sensors called muscle spindles. These spindles are quite literally the brain's eyes inside your body. Every single time you move, these sensors stretch and instantly fire off signals to the brain. This creates something called proprioception, which is basically your brain's ability to know exactly where your arms, legs, and core are in 3D space without you ever having to look down at them. And this brilliantly illustrates what happens when this intricate wiring goes wrong. On one hand, a healthy, freely moving spinal segment provides a constant, highly accurate data feed straight to the brain. But a vertebral subluxation, that's a dysfunctional, stuck spinal segment. When a joint stops moving normally, those tiny muscle spindles we just talked about, they stop stretching. Suddenly, that specific sensory data feed just goes completely dark. The brain's eyes in that part of the body are suddenly blindfolded. It doesn't know exactly what's happening there anymore. So what does it do? It's forced to guess. Which leads us into Section 3, glitches in the matrix, or tripping in the dark. Because when the brain has to guess about your body's position, mistakes absolutely happen. Imagine you've lived in the exact same house your entire life. One night the power goes out. You're walking down a familiar, completely dark corridor. Because you know the house so well, your brain relies on memory to guess the layout. You confidently take a step, but someone left a bicycle in the hallway. You trip and fall hard. This is exactly what happens in your body when you have a subluxation. The brain is quite literally in the dark. It's relying on old data to move your body, but because it can't see the real-time obstacles, it sends slightly faulty commands to your muscles. You become a little clumsier, a little less coordinated, and suddenly you're apologizing to door frames you just accidentally bumped into. And this brings up the fascinating concept of the 1,000 straws. You see, pain rarely just happens out of nowhere. When your spinal feed is sending bad data, your brain starts recruiting muscles in the wrong order. It alters how you move just to protect you. This causes tiny microtraumas, day after day. It's the 999 straws slowly piling up on the camel's back. You probably don't feel a single thing while this faulty muscle control is accumulating. But then, you bend over to pick up a pencil, literally just a pencil, the 1,000th straw. The camel's back breaks, and suddenly you're in pure agony. So, how do we fix it? Let's check out Section 4, Rebooting the System, the Science of the Adjustment. How do we fix these glitches and turn the lights back on in that dark corridor? Well, a chiropractic adjustment isn't just about stretching muscles. It is a highly specific neurological intervention. And the speed required here is genuinely incredible. Research shows an effective adjustment must be incredibly fast. We're talking delivered in under 200 milliseconds. When applied that rapidly, it quickly stretches those paraspinal muscles, firing off a massive burst of information from the muscle spindles straight up to the brain. It acts exactly like a physiological system reboot, clearing out all that background noise and restoring accurate, high-speed communication. So the crucial point here is this incredible figure, 40%. A really remarkable study looked at healthy young men who had a glitch in their system. Their brains were actually failing to pre-activate their core abdominal muscles before moving their arms, which was leaving their spines totally vulnerable to injury. After just one single session of adjusting the dysfunctional joints in their pelvis, there was an almost 40% improvement in their brain's ability to correctly fire those core stabilizing muscles. One quick system reboot, and their brain instantly upgraded its protective control over the entire body. No way, right? And the scientific evidence for this neurological reboot is just phenomenal. Research shows that correcting spinal dysfunction actually improves proprioception, meaning your brain's awareness of where your ankle is in space gets tangibly better. It speeds up reaction times, specifically how fast older adults can take a sudden step to prevent a fall. It actually increases the strength of your leg muscles and reduces muscle fatigue simply because the brain is finally sending a clearer, stronger signal down to the muscles. It even alters visual acuity and changes how the brain processes visual illusions. I mean, by fixing the spine, you are literally upgrading the entire processing power of the brain. Let's move to Section 5, the power of posture and how your spine actually shapes your mood. Let's bring this into your daily life, because every single day, the physical shape of your spine is sending constant data to your brain. Looking down at a phone, that classic text neck, or slouching at your desk doesn't just look bad. Science shows it restricts your deep breathing, which alters your brain chemistry, actually increasing feelings of fear and lowering your ability to handle a stressful task. On the flip side, holding a strong, upright posture enables full breathing capacity. But way more than that. Neurologically speaking, it boosts self-esteem, improves your mood, and increases your resilience to stress. Your physical posture literally shifts your psychological reality. So I want to leave you with this final, really provocative thought. Your brain is, right now, actively constructing your reality based heavily on the physical data it's receiving from your spine. So, how are you holding your spine right at this very moment? Are you feeding your brain a reality of stress, slouching, and blind spots? Or are you sitting up straight, turning the lights on in your nervous system, and taking absolute control of your inner matrix? It might just be time to sit up, take a deep breath, and upgrade your reality. Thanks so much for joining me on this explainer, and I'll see you next time.